So in this video, I'm going to talk about bonds and yield rates. So when you invest on bonds, one of the you can reinvest coupon payments. So when you reinvest coupon payments, you may want to know what is your final rate of return for investing on that bond. So we would like to calculate total return for investing on bond. So at this point, you need to remember that we are talking about two different rates. When you invest bonds, so you have the bond price, which is, if I use the basic price formula, this is the present value of all future coupons plus present value of redemption amount. Okay. So whenever we talk about present value, you need to talk about the rate you are using to discount it. So this one present value, you have discount. So basically with the present value, you have the discounting rate. Okay. Basically, you have this v to the sum power t, and v equal 1 plus I to the power negative 1. Then this rate, that is basically the yield rate. Okay. So this is if you do not reinvest coupon. Okay. So in this case, your yield rate become the rate you use to discount. So then yield rate is the rate you use to discount cash flows. Okay. Now, sometime this is not true. Okay, so you are not going to just keep the bond until it mature. Okay, so this happen when? Basically, this happen when you keep the bond until mature. Okay, and you don't, and no reinvestment. Okay. So sometime what's going to happen, you can reinvest the future coupon. So every 6 months, let's say you get $100, and then you can deposit it into your bank, and then you have some, or you can invest that $100 in somewhere else. So then you need to know, like, what is the real rate of return on this investment. So then the approach would be, so we use the general formula. So we have the future value equal present value times 1 plus I to the t. Okay. So in this case, present value is the price you paid to buy the bond. Okay, and the future value would be the total accumulated value of cash flows stemming from the bond investment. And then this I become then the yield rate. Okay, so let me explain this. So this is time t is basically the mature time. Okay, maturity. So let me explain what this means. So you can have this scenario. Okay, so you have this bond times 0, you pay the p percent value. So and then you have 1, 2, 3, so forth up to n. So you are getting coupons plus c. Okay. So this is, you keep the bond until maturity. Then what you can do a little bit tweak to this investment. So what you do, you invest this coupon, reinvest in a bank account. Okay, so whenever you get the coupon amount, you deposit it into a bank account. Okay, so you are reinvesting. Reinvest coupon amount. Okay, so you are reinvesting coupon. So when this happens, you cannot just say, okay, the rate I used to find the price, let's say J, that is your yield rate. That's not true because you reinvest the coupon, so you are getting more. So the correct approach would be, let me use a different color. Correct approach would be, so here you have the, let me draw the timeline. 0. Here you have the present value or the price you paid to buy the bond. Then here at N, you have the redemption amount, of course, then plus the accumulation of these coupon amount. Okay. So basically, I can just say in here, you have the future value. What is future value? Future value is basically accumulated value from the redemption. That one is just C actually, okay, plus coupon reinvestment. Okay. So then you can just write this formula, future value equal present value time 1 plus I to the, in this case, time is N, and then solve for I. And this become your effective yield rate. Now it can be 6 months if you have 6 month time frame. If it can be annual, so you have to adjust based on your requirement, but it is effective. Okay, effective yield rate per time unit. Okay. So time unit you have to adjust based on the question itself. So this is the approach. Now, for example, let's say you decide to sell the bond. Okay, so this is very different from keeping the bond until mature. Okay, so you have 0, 1, and then somewhere time t you decide to sell it. Okay, so let's say you get the coupon and then you sell at price, let's say P2. Okay, so this is selling price. Okay. It's supposed to mature at time N. Okay, this is maturity. So the idea is sell the bond before mature. So here you would pay the price. Okay, so you are paying the price. At the very beginning, you thought you were hoping to keep it until mature. Okay, so this one, price was calculated thinking you are going to keep the bond until mature. Okay, so basically price P would be what? FR AN some rate J plus C VN, because you are hoping to keep it until mature. Okay, so that's the price, no? That's what you paid. Then now you decide to sell at time T. Okay, you decide, okay, I don't want to keep this until time N. I want to sell because the market is really good for bonds, to sell the bond. So I'm going to sell it. Okay, so and then before time N, like somewhere time T, you decide to sell at price P2. So this is selling price. And then also at some the coupon you received until that, you reinvest. Reinvested in another saving account. So every time you get a coupon, you will deposit it to saving account. So now this become really non-traditional problem. So how you get the yield rate? You can't say J is your yield rate. That's not true, because that is just to find the price at very beginning. So the way to do this one, you would say, okay, this is how much I paid. So this is the present value, or PV. Okay. Then the future value is basically accumulated coupon payments in the bank, plus the price you are going to receive from selling it, P2. Price you will receive from selling the bond. So now you can just write that nice formula, future value equal present value time 1 plus I to the t, because you are selling at time t. Okay. From here you can get that. Okay. So how you get the current coupon payment in the bank? Of course, we know that this is look like what? This is look like annuity immediate. And then at time t, what is the equivalent value? FRST, no? That's how you get the equivalent value. So that would be what in here, accumulated coupon payment, because it's growing in the bank account. Why you need to calculate accumulated? Why not just say it's T time FR? This is because coupon, the reinvested coupon payments are growing and in saving account. So you have some rate in the saving account. Okay. So you have to find, so the rate here, so let me write this one. Okay. So again, FRST, but what rate? Is it J or is it I? It's not I, it's not J. It is something different. So this is like, let me write a K. What is K? Saving account rate. In the saving account, you will get some rate, no? So that rate you have to, because that's how the money is growing in the saving account. Okay. So anyway, so you have to calculate this future value using accumulated coupon payment plus price you will receive from selling the bond. So then that would be future value, and then you would use this nice formula. So that's the idea of this yield rate, bonds and yield rate. If you don't sell the bond, if you don't reinvest, then yes, you can get the yield rate just using the discount rate, the scenario one. If you do not reinvest your coupon. Okay. But any other situation, you have to use this formula and then get the yield rate. So here you can read the discussion. This is very similar to traditional yield rate. We calculate at the very beginning. Suppose investor buy a bond at current market price and hold it until maturity. The total rate of return is called by yield to maturity. You can calculate using this one. Okay. Even if it is not hold until mature, you can calculate this using this approach. Okay. So this one, find the yield to mature for 18 years, 6% coupon bond selling $700.89 per 1,000 par value. So this one is basically bond held until mature, no reinvestment of coupons. Okay, so that scenario. So in that sense, actually the discount rate become the yield rate. So but that means basically you write the price, which is 709 cents, equal coupon. A is annual coupon, so it's 18. Some rate, we need to find that rate, and then it's I think it's the redemption amount is 1000, and then V18. V is 1 plus I to the power negative 1. So what you do, you enter this into calculator. So basically you would say N is 18, I over Y, that's what you want to find. Compounding per year 1, payment per year 1, future value is 1000. Present value is, you have to enter negative because you have to pay, so it's negative. And then solve for payment. What's the payment? Coupon amount. It is 1000 times 6%. So which is 60. Okay. So let's use our calculator and see what do we get. So second reset. So I have 1000 as future value, 789 cents, but negative sign, and then present value, 60 for payment, 18 for N, and then compute IOY 9.54. So the rate is so that would be the yield rate. This is the yield rate. Okay. So that's the yield rate. So the example so same. But sometimes you will, I actually don't have an example here, but sometimes you will see that the coupon amounts are reinvested. When that happens, you need to take that into account. So let's say, let me add another line here, okay, plus coupons are reinvested at rate of, let's say, around 5%. Okay, so saving account rates are not that high. So annual effective. So let's say you do this modification. What happened? So now the coupon amount. So what's the coupon amount? 11% for 1000. So yeah, so it's going to be $110. That's a really high, by the way, high coupon amount. So now let's try to calculate the yield rate. So what's going to happen? Every time you get a coupon, you would deposit into saving account. So this is how the saving account look like. You get $110, so you deposit. And then this is going to continue for 19 years. Okay. Now for the saving account, the rate is not 11%, it's 5%. Okay. So the accumulated value after 19 years for coupons, it is not 110 times 90. Okay, that's not true. Okay. Why it's not true? Because you are reinvesting. So it's that money is going to grow. So it's actually 110 times S19 under rate 5%. We just add that. Okay. So here I said that it's going to be 5%. Okay. We are reinvesting. So then the accumulated value for coupon would be, let me use this. So how do you get this one? This is N is 19. Payment is 110. Present value is 0. Future value what you want. I over Y is 5%. This is, we said, annual effective. So payment per year And the coupon also, we are receiving only 1 per year. So payment per year is 1, and the compounding in the account is 1. Okay. So if I use this one, let me use my calculator. Let me reset this. Reset, enter. Now let's enter this value, 19 for N, 110 for payment, and 0 for percent value, 5 for IOY, then compute future value. So I would get 3,359. And 3,059. That's the future value. Okay. So now, so we got this future value. This is just accumulated value of coupon. Okay, so I can draw the timeline. At 0, I paid what? This much to buy this one. And then at time 19, I have 3,359.29 plus the redemption amount. So we assume it's 1,000. Okay, power value 1. Okay, so this is redemption amount. This is from reinvesting coupon. Okay. So now you can see the present value. So if I write future value equal present value time 1 plus I to the 19, then from here you get future value is, when you add this, it's going to be 4,359.29 equal 1,233.64 times 1 plus I to the 19. From here I can get I. So let's solve it and see what do we get. So I'm getting 6.8695 as the rate. So that is the yield rate for this investment. So this is the approach you use. In this case, actually, we assume that we did the modification problem. We assume that coupons are reinvesting at rate of 5%. So then we would get this kind of a yield rate. Okay, so let's meet again in the next video.